All right, welcome back to another episode with Sharp Education. Today, we're going to be building on logistic regression outputs in the same way we sort of built on our linear regression outputs. And I understand that this is a quantitative finance channel. And the more exciting part of these sorts of series is always building the strategies, testing them, and then seeing if they work or not. But as you might have noticed with our linear regression portion of this series, I'm not all too interested in just giving you guys tools, showing you guys how you can modify the adjustments, and then looking at the results and seeing if they work or not. A really fundamental understanding of what even is going on is super important for a couple of reasons. One, you can tailor them how you like. When you see something suspicious, you can fix those. And if you want different parameters in your models, you know how to insert those if you are going on your own route, which I encourage you to do. Additionally, if you're interested in going the quantitative finance route and you eventually have maybe an interview, an introductory interview, a valid question, for example, would be like, what are the four parts of linear regression? Or what are the four necessary assumptions to trust the outputs from your regression analysis? And if you've been following along and you memorized the outputs from your studies that you now get with these codes, you can say, oh my gosh, linear regression. If in order for the outputs to be allowed, you need to see linearity, normality, homoscedasticity, and no autocorrelation, so independence of errors. And then you can trust the outputs, and that's a really strong answer. And I want to give you guys that same sort of understanding of what you're looking for with logistic regression. Now, logistic regression we've already been over. It's sort of just a 1 or a 0. And your outputs, you could see the logistic regression outputs, which we have here. And you can see these, low p-values, and our accuracy rate is not very high, but you could just have this and say, okay, well, look, logistic regression. But a really good understanding of it will teach you how to use logistic regression in much more advanced strategies that you might come up with that I haven't even thought about. So today we're going to be talking about what logistic regression is even doing. How does it make a 1 or a 0? Why does it think that? Like, what is the function that causes all of the outputs that were originally linear? Remember our residuals that were in percent changes. How does it just suddenly become a 1 or a 0? That is through a function called sigmoid. The sigmoid function is one of my favorites, and I know it's weird to have a favorite function, but this one is elegant and I use it often because I like logistic regression. So, what is a sigmoid function? It looks like this. So it's 1 divided by 1 plus Euler's number to the power of negative x. And what that does is it compresses any output or any input to this function between 0 and 1. If you might have been familiar with, if you've taken any basic, maybe advanced little algebra courses or introductory statistics courses. No, some maybe calculus AB. You'll remember that the derivative of e to the x is also e to the x. So seeing this small e to the negative x should ring some bells. 1 divided by 1 plus Euler's number to the negative x is always going to compress values between 1 and negative 1. And we're going to write this function just to show you guys that no matter how big or small these numbers are, or negative, I guess negative small, negative big isn't a real thing. I forget. No matter what the magnitude of our output is, it's going to be between 0 and 1. And that's how we decipher between something that is a 1 or a 0 by defining our cutoff, which we have set to be 0.5. And if you look at this function, you'll notice that the line that is drawn by the sigmoid function intersects with the y-intercept at 0.5 where we set our cutoff. And you can adjust that manually, but we're not going to do that in this series. So let's define sigmoid. And this is just going to be for the purpose of understanding what's going on, so we can input any value into this function and I'll show you what happens at the end. Sigmoid of x. So we're going to return 1 divided by 1 plus numpy dot e Yep, to the power of negative x. And I'm not sure if negative x works. We might have to do x times negative 1. We'll just do negative x. And then what happens when we do sigmoid of 10? Yeah, numpy is not defined. Oh, okay. We have numpy imported at the top of this function, so when we run everything, great. So you can see that even when we have an output of 10, our response is less than 1. What if we have an input of 10,000? So with float point error, it just rounds to 1. But we're never going to get outputs, or just 10,000. We're not going to get a 1,000 value output because within logistic regression, all of our coefficients are extremely small. Great. And then what if we do negative 50, negative 30? So that's still really, really small, like 0.00014 times 9, but it's not below 0. So no matter what value we put in, negative 3 is negative 0.04, negative 1 is 0.26, and 1 is going to be 0.73. So no matter what value we put in, it's always going to be between 0 and 1. And the closer a value is to 1 or 0, the more confident a model is in the outcome of that function. So if we get a logistic regression multiplicative value that spits us out, like say we multiply all of our features by all of our constants, or by all of our coefficients, we add the constant to it, and we get a value of 0.8. So we get a value of 0.8 at the end of our function. So what that ends up meaning is on this line chart here, we have 0.68. So the y value is 0.68. Which is pretty confident. But most of our values are going to be pretty close to 0. And when we have a value of 0, that means our guess is close to 0.5. And when it's close to 0.5, we don't really know if it's positive or negative. But we are going to have, despite how small these coefficients are, variance. So it's not going to always be 0. It's usually going to be 0.01 or 0.02 with the really weak indicators we're using, like MACD, MFI, Bollinger Bands. We've already seen that with our linear regression outputs, they're not super strong indicators. Same thing goes for logistic regression, even predicting up or down. But what we're going to notice is we're going to see super small outputs to our model. For every prediction value, all of our predicted values are going to range between these two values here, more or less. And the responses are going to be the y values. So what's going to happen is we're going to be multiplying our features values by their correlation coefficients. We're going to be adding the coefficient. We're going to be adding the constant to the product of all of those features and their coefficients. And then we're going to be inputting that result into the sigmoid function. The sigmoid function is going to return this value here. And that's going to be our distribution of results. So it's no longer going to look like this distribution here, where we have a distribution of residuals that is centered around 0. It's going to be centered around 0.5 or whatever the... Actually, I'm getting ahead of myself, but the distribution is going to look different of our residuals. Now, this is the best way I can explain logistic regression compression into a 0 or 1. But there are a ton of other videos that might be more informative. So I wanted to get you guys introduced to how logistic regression works before we just started spamming the outputs and showing you guys things that meant nothing to you. I recommend looking at other YouTube videos on what is logistic regression? How does sigmoid activation work? But if that's not interesting to you and you just want to get straight to trading, we got 2 more episodes of knowledge before we start building strategies around this framework. So congratulations for sticking around. I know this is, again, not the most exciting content, but it is important. And if you understand it and if it's still engaging to you, if you like it, you're in the right place. This is the type of knowledge that you need to have a competitive approach to trading. You can't really compete looking at charts. This is the sort of knowledge that is important to have if you want to understand a trading strategy that is competitive in the stock market. So if you're still here, congratulations. You are among the small group of people who I believe has the potential to compete in the stock market. I greatly appreciate you sticking around. Leave a comment, like, subscribe. I can't believe I'm a YouTuber now. I say all that, but that's what it is. Until next time, stay sharp.